Alright, so we're going to be looking at finding slope, and in this first video we're looking at finding slope from graphs and then also looking at finding slope from equations, okay, from linear equations. Now, when we're talking about slope, let's first understand what slope is. Slope describes the steepness of a given line, okay, so if we have a line, it describes the steepness of the line, okay. Now, oftentimes when we're talking about the steepness, we're talking about the vertical change, okay, as we look at the line on a graph over here, it's vertical change versus its horizontal change. Or you might also hear it more often, instead of vertical change over horizontal change, more often than not, you'll hear it as rise over run. Okay, rise over run. And slope is often represented with the letter M. Okay, so we often represent slope with the letter M. So M equals, let's say, 2. Okay, so we're saying the slope of the given equation or the given graph or whatever it happens to be would be 2. Okay, now when we're talking about vertical, when we talk about the vertical or the rise of our graph or the rise here, we're saying the vertical looks at the y values, meaning up or down. Okay, when we refer to up, we're talking about positive. When we refer to down, we're talking about negative. Now, as we go through these graphs, whenever we run into the slope, anytime we have a positive slope, we're going to go up. Anytime we have a negative slope, we're going to go down. Okay, then when we're talking about horizontal, okay, even though it says right is positive, left is negative, it would just help us if we always go to the right and use the negative to go up or down. Okay, so if we have a positive, we'll go up. If we have a negative, we'll go down. That'll just save us a headache. But horizontal, again, that's the x values, left and right. Right would be positive, left would be negative. Okay, now in terms of looking at slope from a graph here, it says a line, in this first example here, a line that is increasing goes up from left to right. So when we're looking at a graph, we look at it just like a textbook. We go from left to right. Or another way to look at it is if I put a little stick figure dude over here, he would have to walk up the mountain, okay? So if he's walking up the mountain, that would be a positive slope. That would be a positive slope. So this image right here, this graph of our line represents positive slope, okay? Now, a line that is decreasing, going down from left to right, so again, going left to right, that's going to be negative slope. Or a way to think of it is I put my little dude over here. He's got to walk downhill. He's got to go downhill, so that would be negative slope. Okay, that would be negative slope. So we can have positive slope, negative slope, and then we'll see a couple other different types of slope we can run into here in a little bit. But when we're dealing with positive slope and negative slope here, when we're describing the steepness of a line that is steep, okay, so a line that has more steepness to it would be more upright, okay, just like that example there. If a line is steep, the slope will be greater than 1, okay? So if we're dealing with a slope that's greater than 1, it is more steep, okay? It's more upright. If we're dealing with a line that is not so steep, in other words, it kind of looks flatter, those guys that are not so steep, their slope would be less than 1, okay? So maybe we're talking about like a fraction, like 1/2, okay? Now, keep in mind, we're talking about the absolute value here of 1 and of the 1, okay? So we might be talking about like a fraction like 1/2. However, there could be a slope like -3, okay? -3 would be a really steep slope, okay? Now, the steepness of a line does not depend on does not depend on if it's positive or negative, okay? So that's what I was just saying there. You're just looking at the number. So don't worry about its sign, you're just looking at the number. So if you just look at the number, if it's greater than 1, it's going to be more steep. If it's less than 1, then it's going to be less steep or it's going to be flatter, okay? Now, let's kind of look at some other slopes that we can kind of run into, and then we'll look at some examples from actual graphs how to find slope. Two other situations of slope that you can run into is a horizontal line that has no slope, okay? If we just have some dude here, again, our little stick figure, he's just chilling out. He's not going left, he's not going right, he's not going up the hill, he's not going down the hill, he's just chilling out. That would be 0 slope. So this says no slope, but that would be 0 slope. Okay, now all of these represent points that are on that line. For instance, 1, 4 here, that would be 1, 4 here. 2, 4 would be 2, 4, 3, 4, and 4, 4. Whoops, didn't hit that very well. 3, 4, and 4, 4. Notice, what do all of these points on that line have in common? Well, each one of them has a y value of 4. Okay, so when we represent a line that is horizontal, it will always be y equals whatever the y value is of each of their points. Okay, so that's kind of what it's saying here. Looking at the table of values, you can tell that the line is going to be horizontal if all the y values are the same. In this case, all the y values are 4. Okay, each one of those points has a y value of 4. If 2 points have the same y values, then the line will be horizontal. Okay, now the way we would represent the equation for this line would be y equals what they all have in common. What do they all have in common? The y value is 4. So anytime we're dealing with a horizontal line that has 0 slope, and its equation would be y equals whatever the y value is in common with each point. Okay, then similarly, but slightly different situation, if we have a vertical line, we say that that slope is undefined. Okay, so my little dude over here, now he's fallen off the cliff and he's scared for dear life. Okay, that would be undefined slope. Okay, now they also give us a set of points that are on this line: 3, -2. So at 3, -2, 3, -1, 3, 0, and 3, 1. All of those points here are on that line. Now, what do these guys have in common? Well, all the x values are what? 3. So similar to this, but not quite the same, all of these guys had a y value of 4. This guy, the vertical line, all the x values are the same. They're all 3. So what do you think the equation is going to be that represents this line? X equals 3. So in the last one, it was y equals 4. In this one, it is x equals 3. So anytime we have an equation that is just x equals a number, that's going to be a vertical line. And a vertical line, the slope is undefined. Okay, so that's what it says here. Looking at a table of values, you can tell that a line is going to be vertical if all the x values are the same. If 2 points have the same x values, the line will be vertical. Okay, so now, the different types of slopes we can have positive slope, negative slope. Slope can be described as more steep in terms of being upright, or not so steep, being flatter. And then also we could have 0 slope, or y equals, okay, y equals whatever the y values are in common. Or we could have vertical slope, which is undefined, which would be x equals whatever the x value they have in common. Okay, now the 4 different ways, I know this says 3 on there, but I scratched that out. The 4 different ways we're going to look to find slope, 2 of them today, but we'll get to the rest eventually, is from a graph. That's what we're doing today. Okay, then from equation, that's also what we're doing today. Then we'll look at finding it from 2 coordinate points and a table of values. So let's just focus on the graph portion first and look at these 2 examples. From the point on the left to the point on the right, in the first graph here, it says you move up 6 spaces and to the right 2 spaces. Okay, now all you have to do when we're trying to find the slope from a graph, you pick any 2 points. It does not matter. Pick any 2 points. In this case, they chose -3, -2, and -1, 4, -1, 4. Pick any 2 points on the line, and all you have to do is count from left to right how to get to your next point. So go to the furthest point on the left. In this case, the furthest point on the left would be -3, -2. Now what we want to do is count how many times we have to go up to get to our next point and how far to the right we have to get to that point. Okay, now it's easiest when we pick nice values. In this case, they did choose nice values. So I'd have to go up 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. So that's what it's saying there. The vertical change here, or we might say the rise of our graph is up 6. Okay? Then I'd have to count how far over do I have to go? 1, 2. Okay? So the horizontal change, or the run of my graph, is I had to go right 2. So the slope here is described as vertical change over horizontal change, or rise over run. Okay, it's that ratio. So my slope of this graph, I had to go up 6, that's positive, right 2, that's positive. So it'd be 6 divided by 2. Well, can we reduce that? Yeah, I can divide out a 2 from both, and we get 6 divided by 2 is 3. 2 divided by 2 is 1. So the slope of my graph, you could say is 3 over 1. That's acceptable. But since it's 3 over 1, we can simplify that further and just say it is 3. So the slope of this line, or the steepness of this line, is 3. Because we had to go up 6 and right 2. 6 over 2 is 3. Okay? Now let's find the slope of this guy. Again, we're focusing on the rise over the run, okay? Or we could say the vertical change or the horizontal change. But we got to pick 2 nice points. In this case, they gave us 2 nice points here. They said the first one is -3, 4. And the second one is 0, -1. Okay? So 2 nice points in the line, and we always go from left to right. Okay? Well, notice if I'm starting, I'm going to use a different color. If I'm starting over here, in this case, to get to this point over here, I actually have to go down. So instead of going up, I have to go down. So I'm going down 1, 2, 3, 4, 5 units. So I have to go down 5 units. So my vertical change or my rise is down 5. Okay? My vertical change or my rise is down 5. Then I also have to count how far over I go to the right, which would be 1, 2, 3. So I had to go to the right. My horizontal change would be right 3 units. Okay? So go back to what we talked about before, though. When we're talking about slope, if I have to go down, okay, if I have to go down, that meant we had a negative slope. Okay, so in our case, if we're going towards our vertical change here, which was down 5, then my slope would be -5, okay, -5 because we had to go down 5, and then right 3, okay, +3. So my slope would be -5 over 3. Now, can I reduce that? No, you should always check to see if you can reduce it, but that's why they have it boxed in here. This is as simple as it can be, so the slope of the line is -5/3. Negative means we have a negative slope, which makes sense because we're decreasing, we're going down. Okay, so that's finding slope from a graph. Then let's talk about finding slope from equations. Okay, so let's look at these examples here. Now, this goes back to what we talked about before in word problems, the y equals mx plus b, right? We always said this guy was the rate of change, okay, the rate. But when we talk about rate of change, that's vertical change over horizontal change. In other words, that guy is the slope. Okay, so if we can rewrite the equation, solve for y just like we did in literal equations, this m here, that's going to be our slope. And isn't that what we said earlier, that we usually represent slope with m? That's what we said at the very beginning. So if I can rearrange these equations so that I can get it into y equals mx plus b form, m is always the slope. So let's look at this guy here. Notice, is this in y equals mx, plus b form? Yeah, so what's my slope going to be? 3. We don't have to solve anything. The slope is going to be 3. That's the answer. That's all there is to it. Let's check this guy. Is this in y equals mx plus b form? Well, yeah, right? Y equals mx plus b. In this case, what's the m? 3/2. Okay, it's okay if you have a fraction for your m. In this case, the slope is 3/2. That's the answer. Okay. Now, the other 2 examples I wanted to remind you of that you could run into. So in the first 2, it was pretty easy. We just saw that m was whatever it happened to be. In this case, it was 3 3/2. But go back to what we talked about before. What type of line is this going to be? Well, that's a horizontal line, right? That's going to be a horizontal line. Now, why do we know it's going to be a horizontal line? Okay, well, that goes back to what we talked about earlier when we were looking at slope. Okay, anytime we had an equation that was y equals, that was going to be a horizontal line. Well, if we have a horizontal line, what do we have for slope? It said no slope or 0 slope, okay? So the slope of a horizontal line is always going to be 0 slope. So in our case, this y equals, this horizontal line, the slope is going to be 0, okay? That's the slope of this line. Now, what type of line is this guy? Well, that was the other guy we talked about. That's going to be a vertical line, Okay, that's going to be a vertical line. And we said for vertical lines, looking at that guy, that's when we had x equals some number. A vertical line, the slope was undefined. Okay, so anytime I have x equals, that's going to be a vertical line, and my slope is undefined. Okay, so we could say m is undefined. Or you might say the slope is undefined. Okay, so in that case, my slope is undefined. Okay, I have a vertical line. Now, in the last two examples here, this is written in that form that we kind of looked at when we were rearranging and solving for y in literal equations. We're going to do the exact same thing here in order to find our slope. So in this first example, let's get y by itself. If that's the case, what needs to move? A positive x. How do you move a positive x? We are going to subtract x from both sides, right, to move it to this side. This goes away and I get y equals a negative x plus 0. Now, is it necessary to put the plus 0? No. So we could just say a negative x. Now, this is in our y equals mx plus b form. So remember, whatever was in front of the x, whatever that number happened to be, that was the slope. What number is in front of this x here? Well, you might say, Mr. Pinksterhouse, there is no number in front of x. Don't forget, guys, if we don't see a number in front of x, what do we always assume it to be? A 1. So this is really y equals a negative 1x, okay? So even though we don't see it, it's a negative 1x. So what is my slope? Negative 1, okay? So the slope here is negative 1, okay? And we could box in our answers from the last ones too. M equals undefined, okay? Normally you would just say the slope is undefined, but as long as you kind of get the idea there, okay? Now, looking at this guy here, whoops. Same thing, we got to get y by itself. What do I move first? Well, remember, we always added or subtracted the x, then divided by y's coefficient. So we're going to subtract 4x from both sides. This goes away, and I get a negative 5y equals a negative 4x and a positive 10. Now, I still have multiplication between the negative 5 and y. How do I get rid of the negative 5? Divide by negative 5 to both sides. And remember, we have to divide it to each piece. So we get y equals, what's a negative over a negative make? A positive. Does 4 or 5 divide evenly? No. So remember, we always left it as a fraction. So this would be 4/5 x, then 10 divided by a negative 2, or excuse me, negative 5. Jump into the answer there. We get negative 2. Okay. Now, what's my slope of this guy? It's in its y equals mx plus b form. What's the slope of this guy? 4/5. Okay. So 4/5 is in front of the x, so that's my slope. Okay.